Okay, so for example, if your fraction is A over B, then the reciprocal is going to be B over A. Right, that's what the word reciprocal means. So the other day we learned three trig ratios. We're now going to learn the reciprocals of those ratios. All right, so the first one that we learned was sine of theta or x, whatever. Doesn't matter, right? Whatever that angle is equal to. And can we remember what sine was? How do we find sine? Thank you. Opposite over hypotenuse. Now the reciprocal of sine is cosec. And the reciprocal is when you take the fraction and you swap it around, right? So if sine was opposite over hypotenuse, cosec is going to be hypotenuse over opposite. All right, we just swap it around. I'll give you a way of remembering just now which one is the reciprocal of which one. So it can get a bit confusing. All right, the next one was cos. So cos theta, we just spoke about it, is adjacent over hypotenuse. The reciprocal of cos is sec. And again, reciprocal means that you take the fraction, you swap it around. So when you take adjacent over hypotenuse and you swap it around, you're going to get hypotenuse over adjacent. The last one, tan of theta, is opposite over adjacent. The reciprocal of tan is going to be cot. And that is going to be adjacent over opposite. By the way that I used to remember it, is that the first letter of the original trig ratio is always the third letter of the reciprocal. So for sine, the first letter is x, the third letter of the reciprocal is also x. For cos, the first letter is c, so the reciprocal, the third letter is also going to be c. I think the last one is easy to remember, right? Turn the odd one out, but again, the first letter is t, so the third letter of the reciprocal is also the suggestion, you don't have to use that way of remembering it, but I would still find that quite useful. Yes. Oh, theta. All right, guys, so in the same way that you were in the exercise asked to find sine and cos and tan of certain angles, they can ask you to find cosec, sec, and cot. All right, what I would suggest is to just remember to try and not actually memorize cosec and hypotenuse over opposite. All right, so then you're going to have 6 of them to remember. Rather remember that cosec is the reciprocal of sine. If you know what sine is, you just swap it around. Okay. I am just going to see what's going on here. Actually, we're not going to practice it just yet. I first want to do the next section and we'll practice it all together. But basically, you just need to know those reciprocals. Okay. We did, but you never really explained what the thing are. Yeah, I'm still getting there. So, Lane is just doing the basics first and then maybe we'll get to that. It's just a new topic, a new, a new reading, a new note. Right, so calculator work, guys. We haven't actually worked with the calculator yet, but we do have to be able to work with calculators for trig. So can we please get our calculators out, everyone? Now guys, just a heads up for 8, you are eventually going to have to get us all the calculator like this. Eventually, not this year, but towards the second half of grade 11, you are going to need the silver one, not the black one. All right, the silver one has extra functions. For example, If you look at that button over there, the black one doesn't have that button. All right, that's an integral button. We're going to use that later on. Yeah, there are other things, but just if I see a special somewhere, that's nice, and I'll let you guys know so you can maybe get it on special. I know that earlier at the beginning of the year, Checkers had a very nice special on it, but that's available now anymore. But yeah, I'll just let you guys know. And maybe if you see this for a nice price somewhere, you can let everyone else know. I'm not sure. All right, so yeah, this eventually has to now, and always the other one will be fine. All right, but for AP eventually you are going to use one of these. Okay, so we are putting the calculator on. Now guys, I want you to find the sine, cos, and tan buttons just to see where they are. Make sure that you know where they are. Now guys, I want you to recognize that there is no cosec, sec, or cos button. All right, can you see that on your calculators? You only have sine, cos, and tan. So whenever they're asking us to calculate something for sec, cosec, and cos, we're going to have to work with reciprocal. Okay, we will practice that. Now we're just going to do a couple of examples, and it's going to seem silly that we're doing these, but so many people type trade stuff incorrectly into the calculator and lose a lot of marks. So let's just make sure that we can all actually do it properly. Use a calculator. To determine, and we're just going to do a bunch of examples. Sine of 30 degrees. Now guys, in the homework, right, they were always asking you, or they were always asking you for sine, cos, or tan of an angle. Right, and it was always like a general angle, like an X or an angle A or theta. But we are eventually going to work with actual angles as well. All right. So sine, when you press the sine button, you'll see that it automatically enters that first bracket. 30. Now guys, if it was sine 30 degrees and then plus a 1, all right, then you would have had to close the bracket. But you don't have to close the bracket if that's the only thing that's there. Then we're just going to press equals and we're going to get a half. If you are not getting a half, then your calculator is in the wrong setting. All right, please just check. Are you getting a half, everyone? Yes, just nod. You getting a half? No. It's supposed to have a D there at the top. If you look in the way I'm pointing, that is supposed to be a D. If you have an R, then it's in the wrong setting. Then you will have to go to, let's now remember, shift, mode, and you can look for degrees. Which is number 3 on mine, it might be different on yours. Just a minute, okay? All right, so sine 30 is equal to a half. There we go, that's the answer. And we're going to come back to this specific ratio. We're going to work on this one quite a lot. All right, so let's just put it on hold for now. But this is a very important ratio that we're going to work with going forward. Okay, number 2, we are doing 2 cos of 85 degrees. Again, you can just type it into the calculator as it is, 2. You can put the cos in if you want, or you can just put the cos in, 85. There's nothing that's coming after that 85, so you don't have to close your bracket, equals 0.17. So this is like the ratio. They've just written it in the irrational. Okay, number 3, sine squared 50. And guys, if we're looking at the calculator, there's no sine squared button, all right? So what you're going to have to do is you're going to have to rewrite this in two possible ways. The first way would be to do the sine 50 element. All right, we can type that into the calculator. We can type in sine 50 and then square it. We just can't type in sine squared 50. All right, but that's what this means. Sine squared 50 means actually sine 50 squared. Or what else can you do? In order to square something, you multiply it by itself. Right, so if you wanted to, you could do this. You could say that sine squared 50 is sine 50 times sine 50. If you wanted to type it in the first way, let me just show you how to do it. You would have to now insert a bracket before the sign, then press sine, then 50. Now guys, because the calculator inserted that bracket automatically, we have to close that bracket, and then I need to put another bracket, right, to close the first one. Does that make sense? Then we can press the square button, and that will give us an answer of 0.5. Let's see, if you wanted to type it in the other way, sine 50 times sine 50, you would say sine 50, now you have to close your bracket. Times sine 50, you will have to close this last bracket, but let's just do it to the next and you will get the same answer. Okay, so it's up to you. If you're worried about brackets and worried whether you will remember to put in enough brackets or whatever, you can just type sine 50 times sine 50. Okay, number 4. Okay, tan of 60 plus 15, so tan, the bracket is there automatically, 60 plus 15. All guys, you can type in 75 straight away. Right, we all know that 60 plus 15 is 75, so you could have done that straight away, and that is then equal to 2 plus root 3. If you don't like that, you can press SD, and it will give you the decimal form. All right, I'll write down both of them. Third form is fine, or if you prefer decimal form, and that is what that S to D stands for, guys. So to decimal. All right, so if you want to go to decimal form, just press that button. 3,7. Number 5. Now we're going to do tan of 60 degrees plus tan of 15 degrees. So tan 60, close bracket, plus tan 15 equals 2. And you notice that is not the same answer as we got from number 4. Yes, you have to close the bracket on the 15. Now guys, this is important. We are going to talk about it more, but this is a common mistake that even my matrics are still making. They think that tan is like a number that you can multiply into a bracket. All right, when in fact it's not. Tan is referring to a ratio of sides. All right, tan refers to the ratio of the opposite side over the adjacent side. All right, so if they're saying here tan of 60, can we have a triangle with a 60-degree angle, guys? Okay, then a triangle with a 60-degree angle and a 90-degree angle. Okay, what will the third angle then be? We have 60 and 90. 30 degrees. All right. So we would have this. And we will talk about this triangle a lot more in future. But just to bring it back into context of what we're actually working out here. Right, that is a valid triangle. Right, do we agree with that? If we add these three angles together, they do add up to 180. And as we remember that for that first note, I think we wrote down that these trig ratios only work in right angle triangles. Right, that's why I put the 90-degree angle in there and 60. Now guys, if we take, for example, what was our first answer? Sine 30. Right, there we have a 30-degree angle. Sine of 30 was a half. Now what is sine again? Sine is opposite over hypotenuse. So we're looking at this 30-degree angle. What side is opposite? That one over there, hey? So that one could be 1. And the hypotenuse is there? 2. That's giving us sine 30 is opposite over hypotenuse, 1 over 2. Right? I got that from the calculator. I'm not making that up. Okay, the calculator told me that. So guys, how can I find this third side? Pythagoras, eh? Can we do that with me? We'll say that the third side is going to be hypotenuse squared, so 2 squared, minus the other side squared, 1 squared, which is obviously just 1. That is equal to 3, but that is this side squared. All right, so this side is then going to be the square root of 3. Right, this is known as one of the special triangles. This is the triangle that you have to memorize and that you have to be able to draw and use to find trig ratios. Basically, what this triangle is saying is that any triangle with these three angles, right, will have sides in these ratios. So they could be double, and we saw this in that Pythagoras investigation that we did in class on Thursday. These could be double. So that could, for example, be a 2 and a 4 and a 2 root 3. Right? But when you're then doing sine 30, you're still going to get opposite over hypotenuse 2 over 4, which is equal to a half. Right? You could triple these, so you could have 3 and 6 and 3 root 3, for example. Right? You would still get a half for sine 30. If you type tan 60 into the calculator, just to check whether it works, tan 60, because we just used it as a part of this calculation, right? We didn't actually calculate it on its own. Tan 60 is just root 3, the square root of 3. Now guys, if we use this triangle, when we get that, tan is opposite over adjacent, root 3 over 1. Right, so this triangle will give us the correct ratio for tan 60. All right, tan 50, I think might give us a different answer, which we're not going to look at now because this is working with rational terms and stuff, which we haven't done yet. Cos 60, let's try that one. Cos of 60 degrees is also a half. Well, this triangle gives me a half for cos 60. What's cos again? Adjacent over hypotenuse. All right, so this is a special triangle, guys. We are going to do a whole note on special triangles later on because there is another one. I just wanted to kind of relate what we're doing now to an actual triangle. Okay, so that it's not just numbers floating around. Okay, so we'll come back to this, but this is a very important triangle in the world of trig. Okay, let's move on. So we've done these calculator word question things. So now let's do number 6. Well, actually, I'm going to use the things and then use a calculator to determine. Now I'm going to say use a calculator to find the value of x between 0 degrees and 90 degrees. When we are having this in a very long time. Yes, by then we will have but by then we will have calculate. Okay, so the first question is just saying sine of x equal to a half. Now guys, why do you think they're saying between 0 and 90? We're working with, what are we working with all the time? Triangle. Okay, we're working with a triangle. So guys, if we're working in a right angle triangle, we already have a 90-degree angle, right? That's a given. So the other angles in this triangle will have to be something between 0 and 90 degrees. Okay, they will both have to be acute angles. We already know what x is going to be here. Sine of what angle is equal to a half? We just spoke about it. Sine of 30. So we know that x is equal to 30. But guys, it's not always going to be such a nice answer. You won't always be able to know it just because we did an example on it just before. So the way in which you can actually separate a trig ratio from the angle is by using, if you look at these sine, cos, and tan buttons, by using the function above the sine, cos, and tan buttons. You guys see there's a sine to the -1, cos to the -1, tan to the -1. Now guys, how am I going to get those? What does that press on the calculator to use those functions? Shift. All right. So let's write this down. Let's say x is going to be equal to sine to the -1, sine because it is sine, right? Of a half. And when you type that into the calculator, it will actually give you the answer. Okay, the calculator then kind of inverses or reverses the process, and it will give you the angle. So when you do shift sine of a half and you press equals, it will give you that angle. Okay, so x is 30 degrees. Number 2, 4 sine x equal to 1. Now guys, just like we solved for x in a normal equation, we want to get everything on the other side. All right, now this is what we have to do in this case. This 4, we need to move to the other side first before we can do shift sign. All right, I can't do shift sign if I solve the 4 on this side. It has to be like in the first equation, sine of an angle equal to a number. Then we can do shift sign. Or cos of an angle equal to a number. Or tan of an angle equal to a number. All right, so we first need to take that 4 over to the other side. We're going to say that sine x is equal to 1 over 4. Am I right? Right, because you are multiplying by 4 on this side, so you're dividing by 4 there. Then we're going to do shift sine. So let's just write that down. Of a quarter. So I'm going to be sneaky. I'm just going to change that 2 there to a 4. Equals 14,48 degrees. And guys, let's remember that when we're solving for x here, x is an angle, right? It's always a trig ratio of a specific angle when you're working with those triangles, right? Sine of x, but x has to have a degree symbol at the end of it too. So that is an angle. Tan of x minus 25 degrees over brackets is equal to 0,465. So guys, what a lot of people tend to do is they say, oh, okay, I'm going to move this minus 25 and I'm going to add it to that side. But guys, this is a number. Remember, this represents a ratio, right? This is like a fraction. It's just been written in decimal form. Then I also add an angle to it. No, these are not the same kinds of numbers, right? They don't represent the same thing. This x minus 25 is the angle. In the two previous questions, the angle was just x. Now the angle that is attached to this tan, right, is x minus 25. So I actually already have a trig ratio and an angle equal to a number. The angle is just more complicated in this case. All right, so what you're going to do is you're going to rewrite that angle just like we rewrote x over here. We're now going to write x minus 25 degrees is equal to just tan, right? Because now it's tan. So we're going to do tan to the negative 1 of 0,465. And we're going to work that out. We're going to say shift tan 0,465 like that. And now that is going to give us an angle value, 24,94 degrees. All right, that's x minus 25. 24,94 degrees. What must I do to get x on its own? Add the 25 degrees to the other side. Now we have degrees and degrees. Now I can actually add those together. All right, so now we're going to say x is equal to, you can do it in your head, you can do it on the calculator, it doesn't matter, 49,94 degrees. And guys, this is just like any other equation, you can take your answer. All right. That's the nice thing about equations. We are actually solving an equation here. You can go back and you can say, let's check if that works. Tan of this answer that I just got minus 25. Let's see, what do I get? 0,465. Okay, so you can, with these trig equations, basically what we're doing now, you can also take your answer, just like with any other equation. Let's see, I'm going to do one more. I'm going to do number 4 here on the side. It is a little bit longer. I'm just trying to save some paper. So we have, this is a fraction, guys. The numerator is cos 2x minus 10 degrees all over 2 equal to 0,091. Oh, sorry. Can I do shift cos immediately? What does I move across first? That's 2, hey? I need to multiply the other side by 2. So I'm going to have cos of 2x minus 10 degrees equal to 0,091 times 2, which is 102. Thank you. Now again, we have a trig ratio and an angle equal to a number. Right? The angle again is just a bit more complicated than these first ones. 2x minus 10. All right, so I should have written that in text anyway. We're going to now say 2x minus 10 degrees equal to shift cos of 0,182. Shift cos 0,182. And we get 79,51 degrees. Now if I'm solving for x, what does I move across first? The 10, hey, minus 10, I'm going to add 10 on the other side. On this side, I'm going to be left with 2x. Obviously, I can do that in my head, but I'm going to have to divide this by 2 as well. So 89,51 degrees. And now we must divide by 2. Right? 44,76 degrees. That is the answer. Guys, it's basically like solving a normal equation. The only new thing is that as soon as you have a trig ratio and an angle equal to a number, you have to do shift of whatever that trig ratio was to get the value of that angle. And after that, we solve for x, like we normally do. Okay, I just wanted to do some reciprocal calculations to see if you haven't looked at that yet. Are we fine with this concept of solving for x during the shift of the trig derivative? All right, this is basically as difficult as a low getting ratio. Okay. Then use a calculator. And guys, like I said already, and like we all saw that there is no button for cosec on the calculator. Right? So unfortunately, I can't just type in cosec 30 and get an answer. The third letter of cosec is S. So that means that it is the reciprocal of sine. Now guys, reciprocal can also work in this way, that cosec 30 is the same as 1 over sine 30. Right? Cosec 30 over 1 is going to be the same as 1 over sine 30. We just underline that S as well. And this we can type into the calculator. Right? 1 over. So what you want to do when you're doing calculations with the reciprocals is you first want to try and write them in terms of sine, cos, or tan, because those are the ones that we have buttons for. Okay, you can do it differently as well. You could find sine 50 first and then find the reciprocal, you know? It's not the same. It's not going to be the same. The sine to the -1 and like x to the -1 is not the same concept. So I know what you're thinking of. You're saying that x to the -1 is 1 over x, which I agree with. But that's not the same thing as sine to the -1.
If you want to say sine 30 is up,
This notation is not the same as when we're working in it. Yeah, I know it is confusing, but yeah, unfortunately it's not the same concept. They're just using this as a notation for the inverse treatment. They don't mean the same thing. All right, so we're going to do 1 over, oh, sorry, you see what I first said? 1 over sine 30. For this, I think let's do, yeah, you do have to close the both. You do have to close the brackets there. Close bracket, and then we get an answer. And guys, isn't that, or that should make sense, right? Because what is sine 50 again? Sine 50 is a half, right? So if you wanted to, you could have just calculated sine 50 on its own, and you could have said that this is 1 over a half. And you can type that into the calculator, or you could have done a different times maneuver, and then you would have gotten an answer. Okay, let's look at another one here. Yes. Yeah, if they've given you the triangle. We just first need to know how to work with the calculator before we start working. Yeah, we can start doing it. Okay, cot squared of 30. Cot, the third letter is a T. So that is the reciprocal of tan. Right, so I'm going to write this as 1 over tan squared of 30. So that in looks a bit strange. And we remember when we're typing tan squared, we need to type tan 30 in brackets squared. Okay, so make sure that you're doing that correctly. So we're doing 1 over bracket tan 30, close bracket twice, and then squared, and then we get an answer of 3. And it's not always going to be a whole number as an answer.
Half resolution.
No, in the question it's saying alright. Yes, this will be the same answer. Yeah, if you did 1 over 10 50 all in brackets squared. Yes, correct. Okay, just one last one, which I'll do here on the side. Sec 40 degrees plus cosec 50. Right, sec, the third method is t, so it's the reciprocal of cos. So we have 1 over cos 14 plus cosec, the third vector is x, and that's 1 over sine 15. One over cos 40, close your bracket, plus 1 over sine 50, close your bracket, equals, it has to be true, y'all, because they have different equals 2,61. Yes, how would you guys also getting? 2,61. Okay, so just, it won't always be a whole number. Nice if it is, okay, but it won't be. Okay, guys, next term, we only have about 10 minutes left now. I just want to show you quickly in the textbook how we are going to apply all of these things. At first, obviously, I had to show you what the ratios are, and now I have to show you how to work with your calculator and actually calculating these things. Next up, and this is actually what trig is used for, is we're going to use it for solving right angle triangles. So for example, if they've given you a triangle here, they're telling you that that is 23 degrees, they've given you one side, and you need to find FG. But usually with a right angle triangle, if we need to find the side, we use Pythagoras. Yes? Do we agree with that? So guys, Pythagoras you can only use if you have the other two sides. So if they're asking us in this triangle to find FG, we only have one other side. We can't possibly use Pythag in this triangle. Okay, we don't have enough information. So what we're going to do then is we're going to use trig instead. So we're going to say, okay, we have a 23-degree angle there. FG is the side that we're trying to find. Do we all agree that FG is the opposite side to the 23-degree angle? And what is the side that we do have? This side is the hypotenuse. Right? Do we see that? Which trig ratio works with opposite and hypotenuse? Sine. So that we can actually say that sine 23 is FG over 20, and then solve that as an equation to get this FG sine. All right, so that is what we're going to be doing on the first day back next term, actually calculating these values in triangles when we don't necessarily have enough information to use Python. I just wanted to give you guys some context as to what we're going to be using trig for. Later on, we're going to be working in the Cartesian plane as well a little bit. Do you remember what the Cartesian plane is? X-axis, Y-axis. Okay, we're going to be using trig in the Cartesian plane as well. And then we're going to be drawing trig graphs. Some of you guys might have seen that little picture of like the guy that's dancing with like his arms are like this. Have you seen that? Yeah. I don't know if I'm doing a good job, but it's like little arms that are wiggling like this. So it's showing like these graphs. So we're gonna draw these graphs next to it. So it's, and then the tan one is also like that. I'll see if I can find it quickly. It's strange that I actually don't have it on my wall anymore. Okay, guys, just a little bit of practice in this. Not too much. I'll give you enough. Or I'll give you. I'll give you just the right amount to finish in this lesson. Sure. Exercise 5.3.
How many said in the same side?
No. Number one, each, oh, guys, these are just the ones where you literally just type into the calculator your answers, so very quickly.
You maybe put the button. Thank you.
Over multiple pages, so it's gonna be a bit difficult.
Oh, that's fine.
The different exercises cover different things. Guys, this one is solving for the angle. This one is solving for the angle, so that's we have to do the shift thing. And then, oh, you're gonna shout at me now, but I'm just gonna give you two of these, I promise. These are reciprocal ones. One A and J. That's it. That's it. Go. Let's see who can finish. I'm your math teacher. I feel like that's definitely an unfair advantage. And is that an A or an O? This is an A. I feel like that's quite obvious. Some of your things today I've been like around A or anyway.